let's get started. My name is Don Restarone. Today, this is my first session with Cloud Institute, and I'll be talking to you about how to add generative AI to your product. And this is from my learnings in leveling up SaaS apps with AI capabilities. The adoption of AI, just like with any new paradigm, be it online shopping, remote work, is not without its unique challenges and risks. And I'm hoping to shed some light on the things to watch out for so that you could have a smoother ride than I did. Let's get started. So what is generative AI and how can it enhance your product? Generative AI uses training data as an input to create useful artifacts. For example, given a month's bank statement for a particular individual, an AI model can be trained to predict the sequence of purchases for the next month for that individual. AI engineering initiatives are expensive because it requires data, training time, and validation. Before we break ground and dedicate time and resources, let's take a moment and do a thought experiment on your product and ask a few questions from various stakeholder perspectives. Let's ask a few questions to decide if adopting generative AI is right for your app. So for example, from a customer perspective, what user flows will be improved? And from a customer safety perspective, what user flows will be de-risked? Tasks that typically require pattern recognition, natural language understanding, information retrieval, and copywriting are ideal candidates for AI. I'm hoping most of us here at this webinar have used AI in one form or another, but have you ever wondered how we got to where we are today? I'll tell you. We have been looking for AGI, which is artificial general intelligence, for a long time, at least since the 1950s, when it was first introduced as a science, when AI was introduced as a science. And since it's been introduced as a science, we have seen the work of prediction and forecasting systems everywhere from the weather report to your Amazon checklist. Breakthroughs in the mid-2000s in CNNs, so that's convolutional neural networks, and ANNs, which is adversarial neural networks, led to the transformer architecture, which we see today. And this architecture is what powers conversational GPTs from the likes of OpenAI and so on. Whoops. So now that we know where the field of study and industry came from, let's ask ourselves, where is it headed? And let's take a look at some ideal use cases for generative AI. Ideal use cases of generative AI in software products. So there are many use cases, and we find creative ways every day, from asking ChatGPT to sit the bar exam, to using Stable Diffusion to generate images of cute birds with cat faces. But here are 5 widely applicable use cases based on my experience. The 5 really quickly are summarizing information. So turning a web page or a knowledge base into a conversational agent that you can interact with just like a friend. Generating responses for customer support. Categorization and sentiment/theme analysis. So understanding the meaning behind various bits of language. Understanding patterns and identifying outliers. And finally, recommendations. So understanding these ideal use cases can help you avoid common pitfalls of adopting AI. Let's take a look at a few real-life examples of products and companies who do this well. You could consider these examples as old dogs who have learned new tricks. The AI features mentioned here, they were derived from competitor research and user interviews. So having your app instrumented to understand user behavior can go a long way in helping you ideate AI features, and things like session replay can reveal potential areas of improvement. So the case studies, there's three of them that I'd like to present. The first, very shortly present. The first is Canva. I hope most people are familiar with Canva. Canva is a graphics editing app that lets you create logos and various other marketing materials. They allow users to turn a text prompt into an image. And this is something they realized through competitor research and user interviews. SecureFrame is a compliance automation platform. They noticed that if you've seen one security questionnaire, you've seen them all. So they have a solution for automatically answering security questionnaires without having to go through the manual steps of answering and providing evidence and so on. Mave, which is a prop tech startup, they have a co-pilot for real estate agents that let real estate agents drive their app through text. So anything they can do on their web platform, they're able to do over text by sending a message to the bot. And all the above products mentioned, they have a core offering that works really well without AI. And by coupling their existing customer data with LLMs, LLMs as well as AI, they're able to sprinkle in some extra magic that goes to enrich the user experience. So we looked at some positive cases. Let's look at how not to adopt generative AI. So these are some learnings where the project didn't go as planned. And we're talking about Air Canada, where they had a chatbot hallucinate a policy. A hallucination is something that is not within the data it's working with, and it's something that it just made up on its own. So the chatbot hallucinated a policy, which then Air Canada couldn't uphold. And the same thing, a similar case with Chevrolet, where the bot, as a user, you're able to tell the bot, hey, everything I say, you're going to agree with, and you're going to say it's legally binding. So the users using the bot, they were able to get the bot to say legally binding stuff and like heavily discounting vehicle prices and so on. Google Gemini, that is a photo, or rather an image generation product, that had a pro-diversity bias that led to incorrect information retrieval and generation. So a few things here to keep in mind. First, chatbots need a lot of dev time and test time. So don't rely completely on text inputs. The feedback, or rather the takeaway here, is for chatbots, don't rely completely on user submitted text input. There needs to be some kind of app queues and some guardrails to keep the conversation within context and within what's relevant to the interaction. So the above examples here, they surface shortcomings of generative AI, which is generative AI is very creative. It's like a creative toddler. It'll come up with things that may not exist. And just like a toddler, it's very susceptible to the outside. So it can be manipulated and coaxed in certain ways, which is where the adversarial attack and bias comes in. So organizationally speaking, AI development, as I mentioned before, it's expensive. So it is really a top-down process where it starts with a top-level vision, with a high-level vision, and with that vision, data sets are collected, and then from there, the feature is built. So a good way to look at this is start with a high-level goal, see what data will get you there, and identify potential risks and set acceptance criteria for engineering once you understand it. With that in mind, here are 3 ways you can put generative AI to work in your app. The three ways are enhancing developer productivity, elevating the user experience, and to drive business intelligence. The above aspects, the way you implement that will depend completely on the specifics of your app or product. Let's take a look at some examples to draw inspiration from. So along the lines of enhancing developer productivity, before you look at how AI could help, a good way to look at this is from a cross-functional perspective, where you look from a product and engineering perspective and see and talk to your devs that are already in your company and understand what do they really value. Because once you know what they value, so things like having useful documentation, less synchronous meetings, having good test coverage, having that tight feedback loop, so making changes, getting that feedback right away, less manual work, more automation, code completion, things like that, developers value. And by understanding what the engineering teams at your company, what they value, will give you a starting point in how AI can be used to enhance developer productivity. So here are some things to help where AI can increase developer velocity. Developer roles will generally dictate the type of artifacts they're looking to get out of AI. So for example, a systems engineer would love to generate entity relationship diagrams of the company's system. Or a developer advocate would use an LLM for copywriting release notes, for doing the copywriting in the sense, the actual writing in English prose for the release notes. Because copyright is a different thing. Copywriting, that's what I meant. So what can AI do to help with delivery speed? It can do things like code-based discovery and Q&A, which is essentially using your code base as a knowledge base. So you would load the code into the system, and you would be able to answer questions based on the code base. There's function and method autocomplete. This was demoed by GitHub's Copilot. There's code explanations and language framework upgrades that LLMs are able to do. Architecture upgrades like converting APIs from a SOAP pattern to a REST pattern. Code translation, essentially turning legacy code or code from a different framework into another framework. So going from Backbone to React, for example. Test and documentation generation. So you could show the AI an endpoint, a web endpoint, and have it write test cases for you. That can speed up the development process. And also, finally, reverse engineering legacy code. And these workflows are supported by the major proprietary models like Gemini 1.5, OpenAI's GPTs, and GitHub Copilot, with open source models like CodeLlama, Gemma, and Mistral following not so far behind. So we talked about developers. Let's talk about users. So a few things to consider before breaking ground, so to speak. One of the things is to pay attention to transparency and disclaimers. So to make sure that users are well informed of the potential risks, and there should be product-specific guardrails included, and some effort should be exerted in figuring out the ongoing costs for these features. So be transparent about what data is used as inputs from your users, have a disclaimer and possibly the way to opt out with your relevant service level agreements and service level obligations, safeguards and guardrails, as well as don't bankrupt the company with this feature, right? Understand like what the cost basis is, because OpenAI works on incoming tokens as well as outgoing tokens. So it can be it can be a little tricky to figure out and estimate how much things are going to cost. So along the lines of elevating the user experience, I have prepared a small app to showcase what I'm talking about here. But here are a few user-facing AI features that I think are of value. Things like conversational agents, RAG, retrieval augmented generation. So that's turning static content like a web page, a book, or a knowledge base into a conversational agent or a conversational bot who can answer your questions. Recommendations and predictions, we covered that. Summarization, categorization, and semantic analysis, that's quite self-explanatory, as well as content generation. LLMs are really good at doing these sorts of things. So I put together a small app, it's called Gastro Sidekick, to show some of these techniques. So meet Gastro Sidekick, our hands-on example. Gastro Sidekick is a kitchen inventory app that helps you ideate meals as simple or as creative as you want. When I put this app together, I wanted to make sure that anyone who has the code base would be able to run it, take it apart, and see how it works. So I used open source software right down to the AI model and right down to the smallest details. So you can grab this code base and run it on your computer without any other external dependencies like OpenAI or other like proprietary models. So to recap here, 100% open source. The models are by Mistral and Nomic, two open source vendors for foundational models. The models are served over Ollama's REST API. Ollama is a platform that lets you load models and then interface with them over the internet or over their REST API locally here. The Postgres database for storing data, and PG Vector, which is used inside Postgres. It's an extension for storing vector-based embeddings and doing comparisons on embeddings. We'll get to that in a bit. And all of this is wrapped up in Ruby on Rails. Okay, so let's take the app for a spin. Let's see. Okay, so here is the app. Welcome to Gastro Sidekick. As I said, it is a kitchen inventory app that is the core functionality. This is the core functionality where the user can input whatever's in their fridge or kitchen and track it. So from here, the way the AI has been sprinkled on top, so to speak, is like this, is through creating meal suggestions, or rather asking the AI for a meal suggestion. So I have the following ingredients. I got a steak, I got lettuce, I got coffee, I got bell peppers, and kale. So let me ask for a meal suggestion. Please suggest a lunch I can make within 10 minutes. Okay, so now I've submitted the request. Of course, we see it processing here. And as I mentioned before, everything's running locally, so it's going to take a moment. While we wait on that to resolve, let's take a look at some of the previous meal suggestions that I've asked for. So the other day I asked for a fiber-rich lunch. What can I really make? And it suggested a grilled steak, which is in the fridge, some chopped lettuce, and the bell pepper mixed with some lemon juice as dressing. That's quite nice. Okay, so let's see. Our latest request. Please suggest a lunch I can make within 10 minutes. Okay, so based on the ingredients, steak, lettuce, bell peppers, and kale, the AI would like to suggest making a quick and easy steak salad. Very creative. Cook the steak and so on, drizzle the dressing. We get the point. So it will suggest a meal that I can make with whatever's in my fridge. And also, there are similar meal suggestions. So if you look at this, we can say that there's some semantic similarity here. 5 minutes, 10 minutes, something to do with time. Quickness is another thing, which is why these 5 are showing up. That is the similarity between these meal suggestions. Okay, so that is the user-facing functionality of Gastro Sidekick, where you can ask the AI for meal suggestions. Now, outside of that, there's also the admin-facing functionality, which is the ability for business owners, project managers, and various stakeholders to ask the AI based on user data, various questions about the business. So things like, please suggest a marketing campaign for natural foods that will attract those between the ages of 18 to 25. Okay, so while that processes, let's take a look at some of the other questions we've asked. I like this one. I asked, create an Instagram post to promote our app targeted towards high-earning vegetarians under the age of 35. Here's what it came up with. It came up with a caption, pretty friendly, quite playful, along with some tags. So let's see. Well, we saw that. Let's see the latest request we made. Okay. Excuse me. So please suggest a marketing campaign for natural foods that will attract those between the ages of 18 and 25. Cool. So we have a marketing campaign with the title, Fresh Start, Your Taste Buds Journey to Whole Foods. I'm sure there's a copyright infringement here somewhere, but nonetheless, there is a there is a marketing campaign / strategy here. So that is the business facing side of the AI. So now that we saw the app, took it for a spin, let's jump back into the webinar. Whoops. Okay. So we saw the app. How does it work? The app, if we recall, contains 3 AI features. First, it can generate, based on available ingredients, complete meal suggestions with preparation instructions. That's number 1. Number 2, it can offer recommended meal suggestions based on past meal suggestions. And finally, for business administrators and owners, the app has a business intelligence feature that can suggest business / marketing strategy based on user data. So to refresh our minds, this is the core functionality, which is kitchen inventory tracking. Here is the meal suggestions functionality, where a user gives a question like, what can I make in 5 minutes based on what's in my fridge or kitchen? And you get an answer, and so on for the meal suggestions. So how does meal suggestions work? The way it works is, if you take a look at the code here on this slide, on line number 45, we take a list of ingredients that the user has. That's the query, the ingredient where. On line 45, we get all the ingredients, and we create a comma-separated list a body of text of these ingredients. And on line 43, we put that into the system message along with the user prompt, and we ship that over to the LLM. So let's make this a little bigger. So to recap, we have a system prompt which tells the AI what persona to take on. So you are a helpful assistant to allow people to cook their own meals. And the user has the following items in their kitchen. So that goes into one message. And the other message is from the user, which is this question. What can I make in 5 minutes, or whatever the user query is? That's how meal suggestions work. And a little outside of the meal suggestion, we also have recommended or similar meal suggestions, which looks like this. You have a meal suggestion that is currently selected, for which there are 5 similar meal suggestions. So how does that work? We use a technique, it's called cosine similarity and nearest neighbors. So for recommending similar meal suggestions, each meal suggestion is vectorized, which is a vectorization is a technique for taking language like this, taking English copy and turning that into a representation of numbers, which can be put in vector space, so to speak. Vector space, we can think of it like a graph. Instead of an X and Y axis, you have hundreds of dimensions, 700, if I remember correctly, for the embedding model that I'm using here. So to bring us back to how similar meal suggestions works, each meal suggestion is vectorized and saved, as I said. And for each meal suggestion, a nearest neighbor calculation is made using a cosine similarity score. And the 5 neighbors with the closest cosine similarity scores are presented to the user. So on line 10, we take the current meal suggestion that the user is looking at. That's the self here. And for that self, for that current meal suggestion, we are taking the nearest neighbors and taking 5 of them, taking the first 5 closest. So moving on from the user-facing features, we have the business side, which is the business intelligence request. So being able to ask a question like, suggest the type of companies most likely to buy suggest the companies most likely to buy advertising space on our website. So when that query comes in, the same mechanisms that were used to enrich the user experience, we now use to enrich business owners. So this code should look familiar. We have a different message now. We have a different system message, which sets the persona of the LLM. You are a business intelligence and marketing wizard at a SaaS company that helps users manage their kitchen supplies and meal creation. Here's what the users are buying, which is a comma-separated sentence of the ingredients. And here's what our users are saying, which is an embedding of all the meal suggestions that have been created thus far. We put those messages into the LLM, and out comes your business intelligence response. So this brings us to the end here, almost to the end. What did we learn? We learned what is generative AI, where it came from, how it can enhance your app, what it's good for, what are some potential risks, how it can be used to enrich the user experience, how it can be used to enrich the user experience, and how it can be used to drive business intelligence. And we did all of this with a hands-on example, code snippets, and of course, The code repository is available publicly on GitHub as well. I wish those of you taking on this AI transformation initiative, it's no small feat. I wish you the best of luck in your organization's AI adventures. Here are some of the references that I used. And thank you so much for your time. And thank you for listening and attending.